Welcome. I'll be showing you how to get set up for running PyTorch on the Queen Mary Andrena GPU cluster using Anaconda. In less than 10 minutes we'll walk through the steps in the process. We'll connect to the logging node using SSH, create a conda environment and install our packages into it. Then we will download some example Python code that uses PyTorch, and afterwards we will create a script to tell the job scheduler the requirements for our job. Finally, we will run the job and check the GPU activity and inspect our results. So we're going to start off by connecting to the login node, which is where jobs are submitted from. The information that we provide here is available on our documentation website. So if you have an active login account, you can connect to andrena.hpc.qmul-its-research from a terminal session. And here you can see on the SSH command, I've included my username on the cluster. Enter your password and you're connected to the front end. Now once you're connected to the front end, you can do all sorts of activities. I'm just going to quickly check the status of the Andrena nodes, and here we can see in this instance all of the GPUs are available and they're empty, signified by that middle column showing that 0 out of 48 cores are in use at this moment. So once we're logged on, the next step is to load Anaconda and then create an environment whereby we can install packages. And then finally we'll install the packages that we need. Okay, firstly I'm using the clear command to clear the screen so you can see a bit better. Then I'm loading the Anaconda application into my environment. I use the module command to do that. The next step is to create an empty conda environment in which we can install packages. I've called mine PyTorch 19. I've added the quiet and yes options to my command to reduce the amount of output and interaction required here, but that's just purely optional. Now, before I actually install packages into the environment, I need to activate the environment with the conda activate command and then the name of the environment. You can now see that the prompt has changed to show the name of the environment that has been activated. Now finally, to actually install PyTorch into our environment, we follow the instructions on the PyTorch website. We've selected conda, Python and CUDA 11.1, and we can copy and paste this command into our active environment. Confirm yes to continue when prompted, and the installation will take a couple of minutes. I've sped up the sequence a little bit here while we're waiting for the packages to be installed, but note that CUDA Toolkit is installed as part of this process, so we don't have to additionally load it as a module when we run our job later on. So the installation is completed, so we can do a quick test to see if the packages have installed okay. With our environment still activated, we can run Python, then import the torch package, and it should load successfully with no errors. To run our code on the cluster, we need to create a job script which specifies the kind of resources that we need to run, and then it also specifies the commands that will be run. And if we're testing PyTorch, then we need some code to run. So on the cluster, I've created a directory called PyTorch, and it's just empty at the moment. And in a repository on GitHub, I've got some code that I'd like to run. So first I'm going to download that code, then afterwards I'll be creating a job script. Rather than downloading the file with wget, alternatively I could have opened a text editor and copied and pasted this code in. Both are valid options. In order to run our code, we'll create a job script which specifies the resources we need for our job and the commands to be executed. And you'll find on the Andrena page of our documentation website there's an example job script which is ideal for this kind of PyTorch job. So let's copy and paste that and then make some minor modifications. As you recall, I called my conda environment PyTorch 19, so let's change that. And let's change the name of the Python script to the one that's in my directory. Now the resources required for the job are pretty much standard for GPU jobs. For a single GPU, we're going to specify 8 cores, 11 gigs of RAM, 1 GPU, and we also ask for the Andrena cluster to be used. Then we submit it using the qsub command. and the name of the job script. The job will enter the queue and will be executed when resources are available. We can see the job has started running immediately and is being executed on SPG 15. We can connect to this node and check the status of the GPUs. Here my code is using GPU device 3, and it's a very simple script, so it only uses about 3% of the GPU. In real world scenarios it will be much nearer to 100%. Our job gets exclusive use of this GPU, and you can also see that 928 MB of RAM are being used out of a possible 40 GB. I press Ctrl+C to exit this view, then I'll use the qstat command to check if my short job has completed yet. There's no output from the command, which shows that I have no jobs currently waiting or running. If I list the contents of my directory, you can see there is a new file which contains the output from the job. You'll notice that the suffix is the same as the job ID number, which is a unique number. So let's inspect the output from the job. The results look correct, and I also included some debugging commands to show which device was being used after we attempted to move onto the GPU.